Every day we use vehicles to get us from one point to another. And if we think about it, we find they all have something in common. Circles. In the form of wheels and gears. Circles are also formed by spinning propellers, rotors, and fans. What is it about circles that make them so useful? Bicycles have been around for about 150 years. When you look at a bike, you'll see it has lots of circular parts. Different types of bikes are used in different ways. The size of the tires, the spokes, and the gears can vary depending on where and how the bike will be ridden. Tire size can affect how a bike will handle on a smooth road or rocky terrain. Spokes are tuned to distribute weight, and gears are key to transforming muscle power into mechanical power. How can changing the size of these circular parts of a bicycle affect its performance? Traffic circles and roundabouts are another way circles, really big circles, help us go from place to place. Their shape keeps vehicles flowing smoothly throughout intersections without using stop signs or signal lights, and parts of a circle show up on an even grander scale in highway designs known as cloverleafs and jug handles. Why do transportation engineers choose circles when they design certain intersections? How do the properties of a circle affect the flow of traffic? But what if you need to control traffic that isn't even on the ground? There are about 50,000 planes in the air every day, and as many as 5,000 in a single hour during the busiest times. Most air traffic controllers never see the aircraft or the passengers whose safety is their responsibility. They track thousands of planes strictly by radar. And each airport has its own radar to monitor takeoffs, landings, and flyovers. Aircraft appear on the radar screens as a series of numbers and letters, designating their airline and flight number. With each sweep of the radar dish, the aircraft's progress is updated. As your flight takes off, the controller at the airport uses radar to make sure it has a clear path. So many circles, and so useful to us as we travel and move around. How do circles help you get from place to place?
The courtyard in your school has mostly been used as a walkway. Not much has been done with it, but the space has potential. This year, there's money in the budget to fix it up. So out go the scraggly shrubs, and in their place, imagine vegetable and flower gardens. Giving art classes a place to sketch, and science classes the chance to study plant life. Just about every department in the school will have a hand in transforming the area, and the task of designing the space is assigned to your math class. The new design will have to incorporate circles. It'll also need to use pathways to connect the entrances and define the different garden beds. What information do you need to have before you can begin designing the gardens and pathways? How will you use the properties of circles in your design?
Every year, your school holds a food drive to help out those in need. As a member of the organizing committee, you're there to accept the non-perishable food donations. Your group will sort out the donations by types of food and packaging. Then set up displays similar to those in a grocery store so people can choose the items they need. Everyone in the community has been very generous this year, so organizing the space will take some work. It's pretty easy to figure out how much room the mac and cheese boxes will take up, but you have a more challenging task. You need to come up with the best way to display the most soup cans. Is there a way to organize the cans so there's not so much wasted space? How can you fit the greatest number of cans into the space you've been allotted?
The most effective tool we have to detect storms and their movement is radar. As a weather radar dish sweeps around, it sends out pulses of energy in the form of microwaves. When the pulse hits an object, such as a raindrop, a signal is bounced back. The more rain, snow, or hailstones that the microwaves bump into, the stronger the return signal. From the amount of energy bouncing back, an image of the storm is created, showing how large it is and how far away. The most intense parts of the storm appear in orange, red, and fuchsia. Over the course of time, radar technicians can figure out how fast and in what direction the storm is moving. In this way, radar helps meteorologists track a deadly storm. giving them time to warn people in its path to take cover or move to safety. Using radar images, how would you determine which cities the storm is going to hit, and where the weather will be most severe?